Okay, let's discuss about part 6, which is definitely ophthalmic ultrasonography. In this topic, we are discussing about imaging artifacts. So, what are the artifacts of USC? Basically, main important artifacts. So, what do you mean by artifacts? So, artifacts are defined as a reflection or echoes that appears on the image but mm, do not correspond to the location or intensity of actual interference in the eye being studied. So, basically, you see the reflection, you see appears there is an echo, but that's not where anything, basically thing, isn't it? If there's anything is not there particularly, but it's just an facade, it's just what you call it, it's just an artifact. Okay, so means reflection and echo appear in the image, but there is nothing there. It's because of many things. The main factors are four factors that is very important factors. Produce production of artifacts depending on the following factors. Remember these four factors, which is very important. The difference in acoustic impedance of the structure being studied by decreasing or increasing the speed of sound. So we know it, isn't it? Increasing and decreasing the speed of sound. So some media with a higher intensity in increase speed of sound. Some media with lower intensity with decrease in speed of sound. The angle of incidence of sound wave on the object. So it really depends whenever the object is really opaque, and the angle of incidence matters. And other is shape of the object. If object is round or if the object is flat, the pathway through which sound has traveled before reaching the object of interest. Because, so let's take example, if we are interested in retina, but it has to pass through something called oil bubble or gas bubble, or it has to pass through the hard PMMA lens or lens with the edge which is sharp and the sound bends there, something like that, isn't it? It's depend upon that. So let's first discuss about the reverberation artifacts. What do you mean by reverberation artifact? Isn't it word is clear? Vibration and reverberation basically means sound came from reflected from the retina and again reflect back from the lens if lens is too hard or anything. So then reverberation occur. We want that sound come hit the retina and directly come out to the probe, but that's not happening there. There is a revibration. Okay, so occurs when sound waves are reflected between the two highly reflecting surfaces. That's what we are trying to do. Basically, sound reflect back and forth between two highly reflective surfaces. This causes an artificial delay in the returning of signal. That's very important because sound is just doing what? Doing two highly reflecting surface back and forth, back and forth, back and forth, something like that. So which reposition and interface further from the port than we actually, isn't it? The most common cause of this type is artifact insufficient coupling agent between the eye and the probe when air bubble can be trapped between the two reverberants. So basically, its common example is whenever you don't use coupling agent sufficiently. So at that particular time, because coupling agent means what? It helps, basically it couples. It helps to transmit the sound from the probe to ocular structure. If you don't have sufficient of coupling agent, then reverberation artifacts is common. I'll show you. Wait. Can you see this artifact? We actually in vitreous there is nothing, but you can see this time reverberation artifacts. See, the reverberation artifact. This caused by the bubble of silicon oil in the anterior chamber, and arrows show the reverberation. See, can you see this type of reverberation? This type of reverberation, which is very common. Okay, which is very common. The second picture, can you see this type of reverberation, which is very common in US? It's very in. Okay, so let me read all the things, which is very important. Artifact due to insufficient coupling between the probe and eye in A, isn't it? So A and B, and this, can you see this? Okay, this this is a pseudophakic eye in young children with a posterior capsular opacification. Okay, the trapped air bubble between the probe and the eye cause reverberation Error added that mimic the intraocular foreign body hinders the proper evaluation of posterior segment. The IOL reverberation are also errored. In figure B, in this figure, that increase in the amount of gel, the artifact disappears. The artifact is commonly encountered in the, when the probe is placed between just superior orbital rim, examine upper eye. So basically means these artifacts may be because of the, sometimes it's because of the IL, yes, in picture B. In compare with the but in compare with the A, B reduction of artifacts are huge, isn't it? But just using coupling agent. So this is another type of artifact. I'll show you pictures. Just try to read something, okay, from ring down or comet tail. Comet tail is common. So occur when small, highly reflective objects such as air bubble or metals, in especially you will see in foreign body cases like foreign body in vitreous. Okay, this occurs due to the vibration of the object that are caused by the ultrasound wave. These vibration cause a change in the return time of the reflected sound, resulting in very high intensity vibration adjacent to the object. These echoes rapidly tail off. This is very important. Rapidly tail off, causing a comet tail effect. The reverberation occurs equidistant and generally decreases strength and increases distance from the probe. Why it is called ring down or comet tail? Comet tail. Can you see this? There is opacity in the lens. Okay, in this picture A. Picture B, can you see this comet type of shadow? And if there is something that is highly reflective, then can you see this shadow comet like comet? So that's what I've taken this picture from this article. Okay. And again, can you see this is the foreign body, isn't it? Very small arrow, thin arrow, and what do you call comet tail artifact? Can you see this comet tail artifact? Yes, that's what I'm talking about. Again, the same foreign body in the comet shape particle, isn't it? Yes. The shadowing is very common. Shadowing, okay, very common. The blockage of sound transmitted by the high reflective intensity. Again, we can call a little bit. Shadowing is very common, but shadowing should be in the place where reflection is expected. Okay, let me show you. Okay, so blockage means when something is highly reflective and it blocks the pathway of sound. This appears as a hypo intensity area behind the bright echo. It's very important to understand because see, to to tell the shadow there must be a light, isn't it? So normally there must be there is a light, but yes, there is something that basically protects that light intensity in USC, whatever I'll tell you. Okay, it can be caused by calcium, gas, bone, air, metal, or gas. Okay, let me show you. See, the metallic foreign body, thin arrow, sorry, thick arrow, in the vitreous cavity, causing the shadow to orbital tissue, block the air, block arrow, black arrow, and the hemorrhage track, thin arrow. See, this is a foreign body, highly reflective, and this hinders the sound wave. That's why, can you see this area, black area? This area is shadow. If suppose if there is no foreign body, if there is nothing, isn't it this area like wide area is same, will be same here too and same here too? Yes, that's what I'm talking about. The normally it should be like this, the upper one, but it is like this because the metal here actually holds the actually holds the sound wave, and the sound wave which cannot pass created a shadow here, which actually we should expect white area because this retina and the sclera, isn't it? So that's what I'm talking about. Same thing is here, shadow caused by opaque calcium. Okay, so in this area, and again same, the revibration caused by the optic or haptic arrow posterior dislocation, basically means the IOL is dislocated and the revibration causes this area revibration point, and the both revibration arrow and shadow artifact can be because large bubble, and it can be there, isn't it? Shadowing, and it's revibration. So where is it? Then reflection artifact. Now the difference in perceived glow contour eroded when the ultrasound beam is transferred edge to the eye. So something like, can you see this reflection artifact? So it's very important. Okay. So angle of incidence of artifact, it produced when the probe is oriented perpendicular to the surface of very smooth and highly reflective interference. Remember when it produced, when the angle of incidence is very important. It can cause some mistaken impression of intraocular foreign body or the calcium. The sound beam perpendicular to the macula can sometimes show the high reflective linear echoes that is mistaken as scar. So let me show you. Picture A, can you see these two arrows here? So basically, angle of incidence artifact B scan vector AI is a pigmented flat lesion in the right eye. And the figure, so see in B and C, whenever angle is changed, is there anything that can be shown? In figure B and C, image is opposite, showing the same high reflective area which changes position, which changes case, confirming that this is an artifact. Here we see something is highly reflective. Angle of incidence changed. Now this area row arrow shows the angle of. Is there anything that is there? No, nothing. Isn't it? So it's very important to note the probe and the vector pass to this area. So it's basically by this. So sometimes the angle of incidence that really matters. So reflective artifact, as I have already shown in one picture, I'll show again, occurs when emitted sound beam transfers the edge of the lens, especially in axial scan. Basically means it transfers from the edge of the lens. Okay, remember that thing. Okay, what is refracting? Basically means whenever you pass wave from the edge, what happens? Diffraction, isn't it? This causes the difference in the perceived posterior globe contours. The peripheral retina appears elevated relative to the central area. Sometimes shadowing may also be caused behind the elevated area. So basically means if you send something from the edge of the lens, transverse edge, basically there is a refraction occurs, then the peripheral area of the retina is perceived as a elevated area. That's very important. This artifact can be avoided by redirecting the probe away from the lenses. So basically means it's depend, this artifact is because of the lenses, and you redirect the wave, basically probe, away from the lenses. So refracting artifact, you see this picture. Okay, in 3.6, the refraction artifact noted the difference in perceived in globe contour arrowheaded. Can you see this difference perceived in arrowhead? Okay, when ultrasound beam is transverse IL. So basically means this is IL, and in case of IL is, you see different type of, because of diffraction, you see if there is nothing, but you can see that posterior pole of retina is elevated and somewhere depression at some point and something shadow like. Okay, there are a lot of things happening, but you must understand this is the reflection artifact. So I think that's it. I have taken a lot of pictures from this book, a lot of pictures from this book. That's a great book. I recommend everyone this book. Okay, so I think it's done. Cheers.